SAS interface that we'll be working on through all of these sessions. So if you can see my screen, it currently shows SAS University Edition, and let me write it for you. So this is a free version which was launched by SAS a while ago for users, beginners especially, to get their hands dirty on SAS, get to know about what programming in SAS feels like, right? And earlier this free version was not available. It's mainly used for people in universities who are doing the projects, let's say around data analysis, modeling, predictive modeling, statistical modeling, and this is something that we'll be using for our training purpose. So one request from all of you is get it installed on your machine, the SAS University Edition. The tutorial or the steps to get it installed on the machine is, I think, very straightforward. All you need to do is go into Google and search for SAS University Edition download. It will take to a link which starts with sas.com, sas.com. The very first link, most likely it will appear as the very first link, and it will take you to the brief steps of how to get it installed on your machine. It will ask you to download a couple of set of files, and it can also provide you step-by-step procedures to execute those set of files and how to get it installed in your machine. So this is fairly straightforward, and it's also required for all of these sessions. So it would be good, and it will help a lot to have it installed on your machine. Platform, once you would have installed, you will have a similar view. You could currently see a lot of text written. That is something that I have written. But let's say if you open it at your end, this is how the screen would most likely look like. Okay, and this is something that I'll just start with. Uh, what are the different sections around the screen, and where does a user gets to work on? Why are there multiple windows? What icons are there on the left, on the top? So we'll get started with that. So SAS University Edition is something that I talked about. This is a free version which SAS launched for beginners to learn SAS. But in real world where uh, projects get executed, data analytics projects get executed, this version is not used. So this is a non-commercial version used launched by SAS. What actually gets used is base SAS or SAS Enterprise Guide, which is also called as SAS EG. So why the difference? Why two versions? Let me explain. So SAS as a statistical software is very costly. So most of the companies, if you have heard of companies, especially in the data analytics space, uh, most of them go for base SAS. Let me just write it for you, whatever I'm saying. Okay. And SAS EG, which is Enterprise Guide, costs a lot. So let's say you guys complete these training sessions on SAS University Edition, and you join a firm where actual work is done on, let's say, SAS. So you'll either work on base SAS or you'll work on SAS EG. And what you will be going to currently is SAS University Edition. So this is a freeware available, and I talked about the steps to how to get it on your machine. Okay. Why is the difference? SAS University Edition, as I told you, is mostly meant for students and beginners, learners who want to learn SAS. So it has its own limitations. You cannot do A to Z of what SAS has to offer on SAS University Edition. So it has limited set of functionalities that the guys can practice on. And it has also limitations around the bulk of data or the data size that you can load on. While these two versions of SAS, base SAS and SAS EG, they work in their full capacity as far as data size goes. Now, what's the difference between base SAS and SAS EG. SAS EG essentially is SAS Enterprise Guide. Base SAS is something where all the work is done using querying by writing the code manually. Okay, there is minimum GUI interface provided to the user. When I say GUI interface, it is essentially a lots of icons and user interfaces where a coder need not code essentially. Okay, so base SAS does not provide that GUI interface, while SAS EG, which is SAS Enterprise Guide, actually cuts that dependency on writing codes manually completely. So it actually enables users to click on certain icons which have their own uh, tasks. So let's say any type of analysis, let's say univariate analysis, a user wants to perform, there would be a specific icon to perform that analysis, and user can do away with writing code for that. So that's where the cost angle comes into picture, and that's where base SAS is mostly used across the industry. Okay, I myself have been working on base SAS for 10 plus years. I've also worked on SAS AG for 2 years, and base SAS is something that is close to my heart because it gives me complete flexibility around what kind of code I can write. And believe me, once you get used to programming, you would have your own style of writing codes. I think you would most likely love writing your own code rather than uh, going through the user interface and clicking some icons and getting the job done. So that again depends on personal preferences and the company that you're working in. But most of the companies in the industry which use SAS use base SAS. I hope I did not confuse you, but just wanted to put this information upfront so that uh, you would know the difference with respect to the version that you will be doing these trainings on, which is SAS University Edition. Well, actual work would be based on either base SAS or SAS. Okay. Now, more about SAS University Edition. There are three main areas, or I should say, three main elements of uh, SAS as a whole, whether it is SAS University Edition, base SAS, or EG. One is your code window, which is which can be seen here. This is where a user gets to do all the querying. So I can write a few lines of code, I can write comments, I can write procedures, I can write SQL steps. People who are familiar with SQL can correlate. So everything with respect to building a query, building a code gets done in the code window. Okay, that's one, and that's the most important window. There are the two windows, which is one is log and one is results. So any programming that a user does needs to be executed. The code needs to be run, right? And the code can either run successfully or it may not run. In both cases, a log is generated, which the system enables the user to see. Let's say the code is not run successfully, then if a log is also not generated, then the user would not know whether the query submitted has run successfully or not. And if it did not run successfully, what kind of errors or warnings did it give? So log window is something that helps the user to know that. And we'll go into more detail into the log window later when we actually run some live queries. All right. There's a third element which is results. It displays the results mostly related to data tables. That is our immediate next topic. So whenever, let's say, and let me just jump a little bit. Let's say we have a data table which has, let's say, 1,000 rows and 10 columns, 10 variables, and we want to see top 5 rows of that data table. And I'll just give an example of data table in a minute. So results window is something that would be used to display those top 5 rows. Okay, just an example, but let me show you a live one. Let's say in another 10 minutes. Okay, so this is with respect to the SAS interface. Now, I talked about code window, log window, and results window. On the left side of the screen, once you install the software on your machine and you open it, you do also need to know, and you would be interested to know what all icons you would see on the left side. So these are just folders or libraries that you would end up using. Okay, and we'll talk about it once, let's say, we are done with data tables and some of the library functions. So we'll talk about them gradually, but let me go step by step so that I do not confuse you a lot in the very first session. All right. So SAS interface is fine. Let's talk about what a data table looks like, and we'll connect the two in a while. Now let me go to my folder and open Excel. I hope you can see my screen. Currently, what you can see is a text file and a CSV file. I'm assuming most of you would have seen or worked on CSVs, which, if double clicked, open as Excel, Microsoft Excel. And I'm assuming you would have worked on Microsoft Excel. So this is a sample data table that I'm displaying. And again, this is a fairly simple topic, just running it to everybody so that we are on the same page, we understand what a data table looks like. Because 90% or more than 90% of the work in SAS is done using a data table, nothing else. So we need to understand what are the different elements of a data table, because we'll be using these elements every now and then in all of these sessions. So what do I mean by elements? Uh, row, column, header. I'm just writing it for you. Variable. So variable essentially is column itself. Okay. Then there's a fourth element which is variable. So these are four elements I wanted to talk about. So as a group, we are familiar with what a variable means when I say variable of a table. Okay. So row is essentially every row that we see in this table. A table essentially is a two-dimensional form of laying out data, which has columns. This table has three columns, A, B, and C. Their name is state, year, and population. And this is again the header part. The way you identify each of these variables is using header. Okay. Now this table has three columns, state, year, and population, and the number of rows this table has is 33. Excluding the header, it has 33 rows. Guys, you might feel that this is very basic stuff, but I just wanted to get through it in the very first session so that if at all we face challenges while understanding rows, observations, column variable, header, or variable type, we would not be talking about it in the later sessions. Just wanted to spend 5 to 10 minutes here on getting through these basics. All right. So when I say rows, it is the number of observations. It's also known as observations. Okay. So we have total 33 number of observations. On top we have header. We have three columns. Okay. These columns are also known as variables. So if anybody were to ask me how many variables this data table has, I would say there are three variables. Now the next level of question could be, what are the variable types that you are observing? So in SAS, there are broadly two types of variables. One is numeric and the other one is character, also called as string. Okay. Now you can make out the first column state is a character variable. I can apply a filter and see the unique values, all are character variables. Year has numeric values, so it's a numeric variable. Similarly, population has numeric values, it's a numeric variable. Okay. All right. So I think we are done with table, and we saw a population data to understand to help us understand all of these individual elements. So we are good. Now let's get back to our SAS session. Now, why did I talk about a table? Because we'll be getting such a table information into SAS. We'll be running some queries on those tables. We'll be performing some functions, and we'll try to see in the log what log does SAS display when we run queries on a table. Because SAS talks about observations, how many observations got impacted, what kind of a data set got created, how many rows did it have, how many variables did it have, things like that. So it's better to connect with respect to the data table or the physical file that we see. Now I think the time is right for me to talk about how to get information into SAS. So we'll not go into each and every detail of how to get information in SAS, but there are basically two broad ways of working around data tables in SAS. One is creating your tables within SAS. Okay. The second way is importing external files into SAS. Hope this is clear. I talked about that more than 90% of the tasks in SAS are done on tables. One example we saw in the Excel that I just displayed, right? And these tables, you can either get this Excel file read into SAS, the population data that we saw, or we can maybe code it into SAS in another way. So these are basically two forms of getting information into SAS. And rest of it, which is analyzing that data for any specific business objective, is done using SAS functionalities and SAS queries. So all of our sessions would involve usage of those SAS functionalities or queries to get a job done. So I will bring in enough business examples so that we can connect what is the task that we are trying to do and what functionality we need to use uh, to get our job done. Okay, so the training will not focus only on okay, these are the 100 type of functionalities SAS has to offer. No. So I listed down the agenda item that we wanted to cover. We're done with SAS working environment. We're done with concept of table in SAS, and we're also done with how to get what different ways are there to get information in SAS. And let me open a new window, a new code window for you, so that we can get started and start understanding how a typical, very basic example of a code looks like. Okay. So let me write some lines of code for you. Let me execute them, and once the execution is done, then I'll try explaining what's been done. Okay. So I've written 5 lines of code. Okay. Let's forget about what the first line or what the last line says. But this should be pretty straightforward. Here, what we are doing is we are passing values. We are passing a value of 5 against a variable v1, and we talked about what variable is in the Excel that we saw. Okay. Yeah. In the second step, we are passing a value of 2 in the variable v2. Okay. So these variables v2 and v1 did not exist before because you saw that I opened the code just now only. So there is no data table which is existing prior to writing my code. This is where I'm creating those variables. Okay. So these are two variables. The value for these two variables will be 5 and 2. And how many rows? We'll see. There is a third variable in which we are not passing a direct value, but we are using the earlier created variables v1 and v2. So we are multiplying whatever values are there in v1 and v2. This is a fairly simple line of code, and let me execute and try to explain what's being done. How does the final output look like? Okay. So our first query, and a lot of stuff seems to have happened, but let's go through the sections that we talked about earlier step by step. So our code window is this. We executed the code. By the way, let me also tell you what did I do to execute the code. I selected everything. I can either do a control A, or let's say if I have multiple lines of code and I want to select a particular piece of query, what I can do is select it using my cursor, and there is a icon on the top which displays a man running, which is usually run icon. So whenever you select a piece of query and you want to execute it, just hit on that icon. That's what I did. SAS understands that the user wants to run this piece of query. It runs it. It displays in the log a whole lot of information. Let's try to understand that. As a first part in the log, it displays what piece of code got run, right? So it starts with copying and pasting the exact query that the user selected and ran. On top of it, there is a lot of stuff which mentions options, no notes. So we can keep it aside for a while. This is a lot of advanced stuff we might not want to cover now. I don't want to confuse you a lot. So first thing that our code displays is the query that was run. Then it displays the information that it has processed. So it says in the note the data set work.data1 has one observations and three variables. So we talked about observations and variables. This is what the SAS log talks about. It says there was a data set, the name is data1, which got created. It had only one row and three columns. And let's view the data right here. Okay, three columns, V1, V2, and V3, and there is only one observation, only one row. And the values we passed can be seen. So simple query, simple output, right? Any queries around it? I would love to answer, but seems like this is pretty straightforward. But if at all there are any queries, I would love to answer. So this actually gives you a feeler of how a small query uh, looks like in SAS. Okay, and we can build upon writing more queries like this. Okay, now one thing which we miss in the log is this part where it says work.data1. That's where I want to introduce the concept of libraries in SAS. So why does it say work dot? Essentially, what SAS has done for us is it has stored this data one in the library with the name work. Okay. Now, why did it do it? Because SAS wants the user to save their work. Let's say if they want any intermediate tables that they are created, SAS actually wants the user to use those intermediate tables. If the table data one is not stored, the user would end up running this code again and again whenever there is a need of this data. Okay, so till the time user does not define a location of his or her own, SAS keeps on saving all the query outputs, specifically data tables, in a library of its own, which is known as work. And the life of this library is as long as this session is open. As soon as I close this session, this library vanishes. It deletes itself, and on similar lines, all the datasets or the files which are stored in that library also vanish. So maybe we do not want that. That is where users end up defining their own libraries, end up defining their own physical locations, because once they are done with the session, everything is gone. So that is something that as a user I would want to avoid. So that is where the concept of libraries come into picture. Let's say I want to save this table data one somewhere on my own folder, so that after 2 days I want to access this table. The table is readily available for me. Okay. Now you might ask, it's very simple to get this table created. Why would I want to save it? So this is a very simple example that I've taken. In actual, there could be a long list of code that user executes and ends up with a final table, or let's say 5 tables in between, right? So let's say 500 lines of code is run and certain 50 tables are achieved. I want to save two out of them. It's easier for me to save those two tables somewhere in my defined library and get to work on them, let's say 2 days after or 1 week after, rather than not having saved anything and after a week having to run the entire 500 lines of code again to get the same two tables. So it helps us save time and effort. That's the essential, I think, utility of having a library. Now, without confusing you any further, let me demonstrate what a library looks like and how do we define it. Now, I talked about some of the folders on the left side, right? So this is where a user can define his or her library. By the way, whenever you get your SAS University edition on your machine, you will start observing the folders on the left. The top two folders, the bottom two folders, SAS Practice and SAS Practice New, are the ones which I created myself. But if you want to create your own folders, you can do so by right clicking on My Folders. Okay, go to Create. Sorry, you have to go to New and go to Folder. So let me just name it User Folder. Okay, you can name it as per your own choice. As soon as I do that, a folder starts appearing under My Folders. Now this is a location that I will use to store my data one which I just created. Okay. So what do I need to do? I need to get the location of this folder because currently I do not know the exact location, and that is something that I need to define the library. So what do? I right click on the folder that I just created, go to properties, it will prompt me with the location of that folder. All I need to do is go to location and select the information which is essentially the path of that folder, do a right click and copy. Close this window and just paste that location on the code window. Also, just encapsulate this location in double quotes. Yeah. Once this part is done, just insert some spaces on the left side. And this is where we'll start defining the library so that our code can understand uh, what path is being used to define a library. Now what I'll write is lib name. This is a functionality that SAS understands. That is why it colors it blue. Okay. Now the next thing that I need to write is what name am I going to assign this library, and I can name it as per my choice. Let me name it as lib1. Okay. Now this is done. All I need to do is at the end I need to insert a semicolon and I am done. Okay. So there are four things that we did. First is we got the location of the folder we created. We need to create a folder first, get the location. That is one, and also encapsulate the folder location in double quotes. You can also do it in single quotes. So it's one and the same thing. That is one part we did. We wrote one functionality which is lib name. The color of the text is blue because this is something that SAS understands, right? Then we need to declare the name that we are going to use for this library. Location is one thing, name is another thing. Okay. And the last thing that we did was end this line with a semicolon. Now there are four elements of this code which help us define a library. I introduce many spaces in between. Those are not necessary. It's just that for code being more readable, I introduce those spaces. If I introduce just one space, that is also enough. SAS will actually treat it the same way compared to had I introduced 10 spaces in between. So let me just get rid of unnecessary spaces. Okay. This is done. I can now execute. So let me select the query and hit the run icon here. Again, something shows up in the log. Let me just go through it. You can currently ignore the first line of the code and the last line of the code, which starts with options. This is something which is a bit advanced for the very first step. Next, what it displays is the query that we ran and some text in blue. Okay, what it says is libref, which essentially means library reference. Lib1 was successfully assigned as follows. So it says lib1, the name of the library, was successfully assigned to this physical location. The physical location is something you can see has forward slashes in it. Okay. Now SAS understands whenever you use lib1 in the code window, it will directly refer to this location at the backend. So all you need to do is define the location once, and you can use lib1 100 times or more than that across the code. SAS will understand every time you run lib1, SAS will understand this is the location the user is talking about. Now, having created a library, how do we use that? Let me save this dataset data1 which I created in this library. Okay, let me do that. So what do I do to save this dataset in this library? I'll write a functionality data, and then I will write the name of the library which I created, which is lib1, and I'll write a dot. Dot essentially separates a library and a dataset. Okay. Now let me write the name of the dataset. Okay. So this line, which we also saw in line 4 on the top, essentially helps me create a new dataset. So whenever SAS uses data, what it means is it is trying to create a new dataset. And what new dataset? The name of the dataset is something that follows immediately. So in a line 4, in the example that we saw earlier, we were trying to create a dataset with the name data1 using this function data. And this is blue because SAS knows it that this is something that this is its own function. Okay, so again here in this line, we're trying to create a data1 in library 1. That's the difference. Now using what? Right? Now either I can write this piece of code again down below. Okay? So this is one, and I'll talk about the other variation. But let me just follow this variation for the while. Earlier, when we ran this code, let me run it again for you. It shows you the output. Let's go to the log. In the log, it says work.data1. So we did not define the library work anywhere before executing this code. First part is the code that we executed. Now in the log it says since the dataset lib1.data1 has been created, it has one observation and three variables. Okay. So now I was talking about the library that we just created, and it's not only the SAS data table that we can store in this library. I can also save lot other information. I can store a physical file in this folder. So the data that we saw earlier, which is population data, I can store it as well here, and I can just show you the steps to do that. What I can do is go to the user folder, right click it, and then go to upload files. It will prompt me this window. It will help me choose files, and before that, what I do is copy the location. So as soon as I do it, I get this location, paste it there, select the file, open it. Now it tells me this is the file that I've selected. Do you want me to upload it? I hit upload, and as soon as I do it, the file gets uploaded there. So earlier we stored a SAS dataset there. Now we have uploaded a CSV file there. On similar lines, we can also store code files. So the code that you're observing on the screen, I can also save it. You can see on the top, currently it's named as program 3. I can save it in this location itself. So I'm assuming you're clear with creating this folder. Once the folder is created, I do a right click, then I go to upload files. It gives me this prompt where it enables me to choose files. As soon as I hit choose files, it will just open folder locations on my machine. I need to guide it to specific folder where the file is lying. Currently it's already done. I select the file, open it. It tells me the files that it is about to upload. It asks for my confirmation. Upload. I hit upload. uploads the file. Okay. Now we saved data table, SAS data table in this folder. We saved a physical file from our local desktop machine. Now we can save the code that we have executed or developed so far. What do I need to do is anywhere on this, either I can go save program or I can do a control S. Okay. As soon as I do it, SAS asks me where do I want to save that code, and it's very obvious. You want to save it in user folder. Just select it. Just give the name of the code, and I would like to give it mention at least the date for today's session, which is 0624. Save this. As soon as I done, the code starts reflecting in the library that I created, and it also starts showing the name. So this is fairly straightforward. Once you have this stuff on your machine, you would get a hang of it. And my request would be, please try stuff. Please try to do some experimentation there. It will help you a lot. It will help you save your work in future. Okay. Now, certain basic essentials about programming in SAS, which earlier I thought I would be covering, but after having uh, done all of these activities, now I think it makes more sense to talk about certain essentials of SAS programming. Okay, and feel free to write it in your notes. So let's start. Every line of code in SAS needs to end by a semicolon. And that's something that you can observe across the lines of code that we develop. Every line of code ends by a semicolon. Okay. All the lines 4 to 8, line number 11, 13 to 17 end with a semicolon. So why do we need to do that? Because SAS understands where exactly a line ends and where does it starts a new line. Okay. Otherwise, if I do not use semicolon, all SAS would understand is this is a single line, and it will be confused to understand different meanings of different lines of code. So, for example, it will not understand essentially if I just run this, all SAS would understand is that these pieces of code are names of the data set, because it will look for a semicolon, it will not find anything, and it will end up assuming whatever I have highlighted currently on the screen is essentially name of a data set. Okay, so that's where it needs to have semicolons in the code. If I do not have semicolons here in these three middle lines, SAS will never be able to understand what variables I'm trying to create. Okay, so it helps me distinguish that there are three variables, there are three different variables that I'm trying to create, and what values I'm passing. So this is the first essentials of working in SAS. Need to separate everything by a semicolon. Okay. Now you would be seeing these horizontal lines in the code. This is something that we did not introduce, that we did not design. SAS plays those lines automatically, and these lines essentially are a visual help for us to see how many pieces of code or pieces of query are there in the SAS. So within user folder, I can create a new folder by doing a new and then go to folder. So let's say I say only codes, it can help me do that. This is up to you. This is as per the user, whatever the user wants to do. If you want to save day wise, session wise folders, that's up to you. I think that would be the best practice to save every session's work in a separate folder. That's something that I do at least at my end, because I want to then maintain a library of what got covered in session 1 and session 2 and so forth. So nice question. Okay, so I was explaining about essentials in SAS programming. I explained about semicolons. Now I was talking about the horizontal lines. It helps me see visually how many different queries exist. But why do you think, and what did I exactly do to have these lines come? Okay, now let me just give you a clue by deleting the learn command. As soon as I delete the first run command, the earlier line which existed has gone. Right? You can see there's a line between line 8 and 9. As soon as I get rid of run, it vanishes. Okay. As soon as I get rid of the last run, the last, so it's still there, no issues. But if I write if I write another piece of code, then I said, yeah. So here the need of run is not there because SAS understands that you're using another data functionality, so it would automatically understand there is a separate line of code the user is using. If I remove data and just keep on writing v1, or let's say v10 is equal to something, or let's say v6 is equal to some value, it will not separate it as a separate piece of query. Okay. So we need, that's where the role of run command comes into picture. So run essentially tells SAS where that piece of code is ending, right? And it helps user to also what I say, it helps the user to also have a visual view of the physical boundary, which actually does not exist physically, but a virtual boundary of different pieces of code. Okay, so every command that you write needs to end by a run command. Every data command that you write needs to end by a run command. But for libnim, we did not use a run command because that's how the libnim functionality is designed. So let me not confuse you further. For now, you can say, let's say if you're writing a data command, a data function, all we need to do is as soon as we realize we're not going to uh, create any further variables, we'll end it using a run command. That is number two. And I think we talked about some of the essential elements earlier. One of them was executing a code. You can either select pieces of code and then run icon. So that is one way, or you can press F3. I Instead of hitting the icon, I'll just hit keyboard stroke as F3. You cannot see it, but let me just do it. So F3 has the same effect of hitting that icon by selecting the code. Okay. So F3 is a keyboard shortcut. So that's the third element. Fourth element is knowing how SAS names its dataset and the code. Okay, and that we can see on the left side of the screen. Now our data table, yeah, how SAS names its dataset. So it has a suffix which is .sas7b. So this is something that you will observe at the end of every dataset, a SAS dataset. What a dataset is. So when I took you through the population data, it again was a data set. Now you can ask what is the SAS data set. Now this is a physical file that we saw, right? And we need to import into the SAS, right? And then we ran some queries, and then we saved it on a physical location. When we are saving it in a physical location, that's how it gets saved as a SAS data set. So there's a difference between SAS dataset versus a normal dataset that you would observe in an Excel file or let's say a text file .txt. So that is one. And any code query that you save has a suffix of .sas. Okay, so that's another one. And we'll talk about some of the other essentials later down the line. Yeah. So one more important topic that I would like to mention now here is that SAS is independent of cases. So SAS is not case sensitive. So it does not do any distinction between, let's say, a data with a name data 1, or let's say the name, if it goes like this, or let's say the name is like this, or let's say the name is like this. All these data sets, if you are trying to create separately, SAS will end up confusing that these are the same data sets. So essentially, SAS is not case sensitive. It does not do any distinction between case, whether it is uppercase or lowercase, of a data set name as well as the variable name. Variable name, as I say, is let's say V1 is same as writing a capital V1. Okay. So these I thought would help you guys down the line, and it will obviously help you skip some of the very basic initial mistakes that users make. Okay. Now let's go back to the agenda that we had. Next, and we covered some of these items. Like in the point number 5, we talked about how to execute code, usage of a semicolon, and commenting. So we'll come to commenting in a while. We'll talk about what commenting in SAS means. Okay, and we did talk about data step. Data step essentially helps the user to define. First of all, it helps to create a data set. Let's say we are running queries with line 3 to 7. What we're doing is creating a data set with the name data1, and for us to do that we need to use this functionality called as data, and we can create new variables, feed it into the data set data1 using this functionality. So there's two ways. Let's say we are creating a fresh data where no other data set is available. We create a fresh using new variables. Let's say I want to create now another data set. Let me just copy this code and take it down below so that you have the code for reference, what all we did. Now I want to create another data set, let's say with the name data2. Okay, and this is the name that I am choosing. It's up to me. And as a user, you can also choose your own names. But try to make these names as intuitive as possible. So instead of, let's say, this actually happens in projects, users go ahead and try naming their datasets like this: AAA, or sometimes more A's, sometimes less A's. So it doesn't tell you anything about what lies in that dataset. So try avoiding these kind of naming conventions. Try to either name it by, let's say, naming it data1, data2, or let's say any information that you want specifically to reflect. Let's say your data has customer level information, so what you can name it as data this step. Let me just delete this alone because otherwise it will not reflect it view. Well, right, data div customer. So this is the name that I've chosen for the data set that I will be creating. So the name has to be intuitive. It should be able to tell you largely what kind of information resides in that data set. By the way, there could be certain constraints around what length of data set I can use. So just keep that in mind. Okay. So what we were trying to do was create data2. Now we can either create data2 afresh like we did it for data1 earlier, or we can make it based on data1. So data1 has three variables: v1, v2, v3. Let's say I want to create another variable v4, and I want to use the value which was stored in v3 using that. Okay, so how do I do that? I use data1 to separate it by spaces, and I'll write why did I leave spaces. What I can do is now I'll create a variable v4 and it will be based on variable v3. Let's say I divide it by a factor which is given to me from somewhere. Just let's say 2.54. Okay, then I close it by 1. Now I am taking a different example. I am creating a data set with the name data2 using data1. I did not do it earlier. I was creating an apparatus for data one. Now I am using it. So for that, I need to tell SAS what is my source data to create data to, and that is where I introduce another functionality which is known as set. Okay, I can introduce some lines so that it's intuitively clear what all elements are there. First element is sorry, naming the dataset that you are creating. Set is used against the source data that you are trying to use to create a new dataset, and then the variable declaration part where let's say you are using a variable which exists in data 1 which is v3 and you want to calculate a new variable v4 which would be placed in data 2, right? So using these four lines of code, nothing will happen to data 1. Yeah, that is something that you should be very clear on. Nothing will happen to data 1. It does not get affected. But using data 1, I will end up creating a new dataset, data 2. Any guesses how many variables or the number of columns data 2 will have? Any want to take a guess? Run this code and you'll know. Let's go to the log first and let's see what it says. First part is the query executed, selected and executed. It says there were one observations read from the dataset data 1. So now the log has changed slightly. Now it talks about the source data that it started reading, and based on that it created a target data. Target data in this case is data 2. It says in the source data that it read there were only one observation. Now it says the new dataset that it has created, the target data, it has one observation and it has four variables. So what SAS has done is it has taken the three original variables from data 1 and it has added one more variable to it, the calculation of which we defined as V4 is equal to V3 upon a factor. Okay, so this is another thing which you need to keep in mind, that any dataset that you are using as a source dataset to create a new dataset, all the variables in that source dataset would be by default included in the final dataset, right? And this is something which happens by default, and you can tweak it. You can either drop some of the variables that you do not want, maybe because of the data size concerns, or maybe due to some other reasons. You can drop some of the variables, and we'll talk about in some of the later sessions. But how does data 2 looks like? This is something that gives you. All the initial variables are carried forward from dataset 1. The final variable v4 is specific to data 2. It is not there in data 1. And that this is where it does the maths. Okay. So we learned about data step and we learned about what a set statement does. Any questions? Now let's go back to our agenda items. One topic that I would like to cover in this session itself is getting data into SAS, and we talked about earlier that one way is to create data by writing codes in SAS, and the other way is by importing physical files from your PC, from your machine, or let's say a data server. So people, those of you who have worked on data servers, databases like a SQL or SQL databases or Oracle based databases, you would understand that data connection could directly be done using a server. That's one of the commonly based, that's one of the most common phenomena in while fetching the data. And the next most common phenomena is dealing with physical files. And most of the files that I have dealt with are txt files, .txt files, and .csv files. Okay, so we'll take that up in a moment. And let me take commenting part as the next item, because we talked about data step along with the set step. Okay. Now, why do I need to do commenting in my code? So the basic requirement is for making the code readable in SAS. So I might want to add few lines of text so that if at all any other user is reviewing my code, the user gets to understand what's being done in the code, right? And the user could be a business user, the user could be a very advanced SAS user, it depends. But irrespective of that, we can comment our code so that it is readable. And it could be for our own reference. Let's say we are reviewing the code after 2 months or 3 months, and we might have forgotten why we wrote that code and why did we wrote that code in that fashion. So comments are essential. So that let me give you an example what kind of comments I'm talking about. I'm writing defining library live one. So this is a text that I want to introduce in the query window, the code window, but I do not want the compiler, the processor, to run the code when I select, let's say, everything and hit icon, hit the run icon. Okay. So what do? I select the comment and I hit the keystroke, control, and question mark. Okay. What it does is it puts in forward slashes before and after the text and an asterisk sign. Okay, let me just repeat that for you. What I do is I select the text which is put as a comment, and then I hit control question mark. So it automatically uh, puts the forward slashes and the asterisks. I can also get it done manually. How do I do that? Before the code, insert a forward slash and an asterisk sign, and at the end of the code, insert an asterisk sign and a forward slash. Now this could be manual if there are, let's say, multiple lines of text that I want to put as a comment. What I'm talking about is, let's say I have multiple lines of text that I want to put as a comment. Let me just copy it for the while. And let's assume that all these 4 lines of text are different. Okay. If I were to comment it manually, I will place forward slash asterisk here and I will do it 4 times across these lines, right? Instead of doing that, I'll rather select the text and hit control question mark. So it will automatically put those special characters before and after the text. So that is where we use uh, control and question mark. So just write it down for you. CTRL plus question mark. So this is the keyboard shortcut to comment any text of code. Now, if I want to uncomment it, because in some cases it could happen, it is not the text but rather a piece of code that I did not want to run. So what I'm saying is, let's say this is a piece of query that initially I did some experimentation on, but it's not a part of my main query, so I want to comment it. So what do? Hit control. Okay. So this became comment. It did not execute. But later, if I realize, oh no, I wanted to use this piece of code for some reason, what do? I select it again, and then I again do control question mark. So it removes the commenting part. So this is one of the other essentials of SAS while working in SAS. Please make a note of it, how to insert comments in SAS. Control question mark. I'll erase this. And similar comment you can write uh, against all of these pieces of code. Okay. Now let's talk about how to create data sets within SAS. So we are not going to import any physical file. We're just going to create our own data set within SAS. By the way, these files, the code files, and the Excels, whatever I use in the sessions, would be provided to you at the end of all these training sessions. So I'll be providing them to the support team from Intellipaat, and they would be sharing the files. And that's a medium that you can use to, in fact, for raising questions also. See, we created a data set, data 1, using these variables, but it had only one observation. We saw that, we can see it again. Let me just run this. So it has only one observation. But how do I introduce more observations? Let's say 10 observations or 5 or 3 observations, right? So I can create data set of my own. And how do I do that? Let's talk about that. So it might involve certain new elements, but let's cover it anyways. Okay. So first element would be data, because whatever I'm doing, I'm going to store it into a data set. So let me name the data set as create data then task. So I've chosen a long name, but I just wanted it to be more intuitive. By having a look at the name of the data set, it's clear what's happening in there. Okay. Up next, what I would do is I would write certain lines of code where I talk about the different rows that I want to include in the data set. So let's say I write some values, uh, let's say 1, and I'll just put spaces in between 1, 2, 3. I'll make it very simple. Then I say 4, 5, 6, 7, space 8, space 9, then 10, space 11, space 12. That's it. So essentially, these are 4 observations in a data set that I'm trying to create. Okay, and I'm just giving you examples how I can do that. And at the end of this, I just say a semicolon. Okay. Now, what's missing is, before saying what's missing, let me talk about what is there. So we have a data set name in place. We have the observations data in place. What we do not have, or what's currently missing, is the name of these variables. Okay, and let me just name them. Let me just call them, let's say, variable X. Let me just call it var space X. The second I can call as var space Y, and the third I can call as var space Z. It is again as per my naming convention. It could be anything. I just chose it so that it looks a little different. Okay. So now we have a data set name. We have header of those variables, and we have the entries for those variables. Okay. But writing the code in this fashion alone will not help me create the data set. So this is where I need to introduce new elements or new statements or new functionalities which will enable me to create this data set. Okay. So let me just go ahead. What do? I write input and then I write data lines. So just bear with me for a second and let me execute the code. Run is something that we are already familiar with, right? So we talked about input and data lines, and let me just execute the code and we'll talk about it. So what are all information we have now? Data set name, variables, how many variables, name of the variables, and the entries which are going to be there again for variables. Let me execute this code. Okay, it seems we have successfully created a table which has 3 variables. The name of the variables is as per what we defined, and the entries, the exact data points in those variables are coming out to be precisely correct. Let's go through the log. I see a question message, but let me take it up in a while. So it says data create and all that. The values are not shown in the log. Okay. It says next. It created a data set with the name that we gave in the library work. It has 4 observations and 3 variables. So unlike the other examples we saw earlier, there were only one observation. Now we have more observations. Okay. Now observe the output. It is same as what we coded in SAS. So in this example, we have not used any external file, any physical file or a database server, while we created data of our own within code. So this is one type of creating data or one type of reading information. Now let me answer. Elements that we wrote, do we need semi don't we need a semicolon every time? So the answer is no, because this is where we are declaring the entries in the data. If we insert a semicolon, let's say after every line, SAS will understand that the user only wants to enter one row of data, which is 1, 2, and 3. And since all these elements are essentially the same, these are what? Data points. These are what? The entries that you want to enter, data entries in variable X, Y, and Z. And since these are of similar nature, they would be put in a similar uh, group without being separated by a semicolon. So that is why there is no semicolon in between. While everywhere else there is a semicolon, because we are talking about different lines of code, we are talking about different elements. So the first line is where name of the dataset is declared. The second line of the code is where variable names are being declared, and input functionality essentially talks about that. Okay. Then there is a third line which is data lines. It tells the code whatever follows will be the actual entries of the data. So data lines, right? And then a run. I hope I did not confuse you much. By using data lines, we can create a data of our own while coding in SAS. There is no dependency on physical files or external databases. Okay. Now we can make it more complicated. We can introduce more variables as we write more column names. But you can clearly see there is a manual effort involved. And let's say if I put it on the first row itself, and let's run the code. So the difference that we see is no data entries being shown in the final table. Let's go to the log to see what has happened. And this is where log helps us, because something has some error has happened, something did not run as per expectation, and that is where the debugging starts. That's where the correction in the code, what correction needs to be made, starts here. So that is how the log is useful. So now it displays down below that the statement is not valid, or it is used out of proper order, right? Because after data lines, it was expecting certain lines of code. Let's say we remove this, okay, then it probably might have run fine. Let me run this. Again, nothing there, because it says there are two semicolons. Let's go to the code. If I get rid of this, by the way, I need to put it in a separate line. That's why. Run the code, one observation in the data. So everything ran fine. But by this, I only end up using one line. If I want to reduce a second row, I need to, without using a semicolon in between, I need to introduce another line of code. So let me just choose some higher values, 2, 2, 2, and then 3, 3, 3. Now let me. Okay, all fine. Right. So guys, this is one way of creating your own data set. Let's say you do not have physical files like the one I had, population data, and you want to get started in SAS. This is one way of creating data. But you need to write values manually, and the effort involved is a bit large compared to, let's say you create a file somewhere in Excel, and it's very easy to create a data table in Excel. Let me create that for you right up front. what I've done is I open a new Excel and I can just provide quickly the name of the variable. It's a var1, var2, var 3, var4. Okay. Now I need to populate values in this. What I can do is I can use Excel functions, and let's say I want to populate numbers between 100 to 1000. So it will help me populate random numbers very quickly. Okay. Now this is a table that I can take to SAS without having to spend that effort of writing all these how many lines? 17 lines of code add to 4 times. I hope you understand the message that I'm trying to convey. It's easier to get it done in, in Excel rather than in SAS.
Yes, it's a very simple question. I wanted to ask, suppose variable y is a function of variable x, or variable x is a function of variable y. Then how to handle the code? So, particularly is my question.
Yeah, so SAS will not make that distinction. All it will go by is how the user is laying that information. So let's say we have three variables x, y, and z. Y is dependent on x and z is dependent on y. So it will not matter for SAS that there actually is a dependency. It will just treat it as data variables. That's it. Nothing else.
No, like if I consider, just if I consider that variable y is equal to variable x plus 10, variable z is equal to variable x plus variable y minus 2.
I got a question. So let's take our example further ahead. The data set that we created. Now we have three variables. Now I want to create a new variable, and let me just take that up in a different data step. So I might not be able to create that. I will not be able to create in the same data lines code. I would need to create a new step. In a different step, I need to do that. So let's say data new, and then I'll use this data set that I created, and let's say I'm creating a variable which is new, and I'm saying whatever equation I want to apply, which is var upon 1 underscore z into say 1.2 var by var, it could be anything, right? Minus. Now you can insert parentheses to make it more readable, so as to know exactly what's happening. Therefore, if your question was, if I want to create values in a variable which are actually dependent or
Right.
connected with some other variables, data lines will not help you, because it will simply take values the way you declare in these orange highlighted values. There is no provision of applying a formula or any calculation right there. But still, you want to create variables that you need to execute a different data step, where you can use the created data set and then put it against set as a source data set and then create a new one. And it's very easy in SAS to perform these mathematical functions. Very easy. It's very straightforward. Okay. Yeah.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.